Let's continue our training session with the linguistic dimension. Well, let's start. Just restart by saying few words about, well, we have seen that we can formalize the linguistic dimension of an ontology by using annotation properties. And we also have seen that there are some limitations that are mainly connected with reasoning issues, with the semantic impact, with the interoperability issues, and also with performance consideration. So that's why we will learn today how to use another approach to insert linguistic information, to attach linguistic information to an ontology by using this model, which is called OntoLex-Lemon, and that is considered a standard de facto for representing lexical data on Semantic Web. This de facto standard was developed in the context of W3C OntoLex community group. And one of the aim of the model is to enrich, as I said, ontologies with linguistic information. So we can attach linguistic information to, for example, properties, object properties we have created, classes we have already created, individuals we didn't create as individuals, but we will do in a few minutes. And that's why it's very useful to formalize in detail linguistic data by using this model. Well, there is a long history. OntoLex-Lemon comes after various attempts to identify some standards to encode linguistic data in the context of Semantic Web. As you can see here, the first attempt was with link info, then we had Lexonto and so on until 2016, when we have the first, 2014, when we have the first use cases for OntoLex-Lemon, and then the final specification released for OntoLex-Lemon released in 2016. And after, in 2019, there was built another module. As we will see, the architecture of the OntoLex-Lemon is based on different modules. And in 2019, we have the last module, lexicographical module. Well, as I said, the architecture is modular, it's very complex. We have 5 main official modules, the core of OntoLex, and we will focus mainly on core today. And then we have decomposition module, and we will work with it also as well. Then we have variation and translation module. We will try to work with it. Then syntax and semantics, and then linguistic metadata. There are other modules that are in progress, such as the module dedicated to morphology or the module called FRAC, that is dedicated to frequency attestations and corpus data. And then there are other private initiatives, such as etymology, just to formalize the etymology of a term, PolyLemon to formalize the polysemy of a term, and TermLex to encode terminological data, okay? Well, this is the core. The main entity of the core is lexical entry, as you can see here. And the lexical entry is the lemma of our dictionary, of our computational lexicon. And a lexical entry can be further specialized into word, multi-word expression, or affix. So word is a lexical entry that consists of a single token. We can have multiple expression. We've seen today, for example, acute angled triangle. So it's a multi-word expression. It's a lexical entry that consists of 2 or more words. And then we have affix, of course. So lexical entry that represents a morpheme, and it can be a suffix, a prefix, an infix, a circumfix attached to the word stem. Then, as we know, a lexical term, can be different forms in a text. No, for example, we have the singular form, the plural form, or the inflection according to different cases, so nominative, dative, accusative, etc. And these are all these forms are instances of the class, individuals of the class form that you can see here. And each lexical entry needs to have at most one canonical form at least one form, okay? We have for each lexical entry one canonical form and other forms. Each lexical entry is then linked to a lexical sense, that is the meaning of this lexical entry. However, we can also link directly a lexical entry to an entity of an ontology, because OntoLex-Lemon is based on the principle of semantics by reference, put forward by Witteler. So we have 2 options. We can create, we will see that in a few minutes, we can create our lexical entry, and then we can link this lexical entry by means of the relation denotes to a concept formalized in an ontology. The second option, the option I prefer, as I'm a linguist, so I think that the meaning is important. The second option is to create an instance of the class lexical sense. So we have the lexical entry, which is linked to a lexical sense by means of the relation sense. And then the sense is linked to an ontology entity. And as you can see, this model is very useful also in an onto-terminology framework, because we have these 2 dimensions, the linguistic dimension, where we have lexical entries, lexical senses, forms, etc. And then we have the ontological level, so the formalization of concepts in an ontology that is linked to a lexical entry of the lexicon. If you want also specify that a lexical entry evokes some lexical concept, if I'm not very sure what lexical concept is, it's a really, yeah, it's a big question. Well, but in the case if you had this necessity to encode also this kind of information, you have this class lexical concept that is a kind of oxymoron, because lexical it's something that pertains to linguistic dimension. A concept is something that belongs to conceptual dimension. So this combination it sounds quite strange. You can create some instances of this class, and this class represents a mental abstraction, a concept, a unit of thought that can be lexicalized by a given collection of senses. The main purpose, well, this class, lexical concept, was mainly introduced to encode the synset of a WordNet. In WordNet, I don't know if you know, WordNet is a model, And this model is based on the concept of synset, so set of synonyms. So this set of synonyms, according to the OntoLex-Lemon, are encoded as lexical concept. So we have terms, lexical entries that evoke the same idea, the same concept. That's why they introduced this class, okay? But we will not working with this class because, as I said, it's a bit complicated also, the definition in itself. Then we have the syntax and semantics module, as I said, and it allows for the description of the syntactic behavior of a word. So if you want, for example, specify the syntactic structures of a word, the syntactic arguments introduced by a word, etc. Okay. Then we have the module decomposition, and we work with this today, that specifies which elements constitute a multi-word. And we have the relation subterm that indicates that a lexical entry is a part of another entry. And then we have the class component, as you can see here. So for example, let's suppose we will do that. Let's suppose we have to formalize the multi-word expression acute angled triangle. This multi-word expression is linked by means of the property subterm to another multi-word expression that is acute angled, that is in turn be further split into constituent components, acute and angled. Then we have the acute angled triangle multi-word expression linked by means of the relation constituent to another component of the multi-word expression, that is triangle. Okay, so just to formalize the components of a multi-word expression. Then we have the variation and translation vartrans module that is very useful if you want to specify, for example, lexical relations, namely derivational relation, for example, the connection between an adjective and adverb, or morphosyntactic relation, or abbreviation relation, for example, to express that a lexical entry is an acronym of another lexical entry. Je sais pas où le... Oh, pardon. Non, non, ça va. Je sais pas si je peux le... Non, ça va. Yeah, sorry. And then we have terminological relation. So relation that can be specified some variation along different axes, for example, ditopic variation, or diaphasic if it's the variation concerns register, diachronic variation, and distratic variations, and then of course sense relations. And there are the many sense relations are hypernym, as we said this morning, synonym, antonymy, and translation, of course, and many others. Why I can
press once there, click, just click with your mouse.
Ah.
No, exactly.
Okay, sorry. And there is this translation modules. Sorry, there is, as I said, the variation and translation module So we have seen the variation, and you see the translation aspects. So translation relates two lexical entries that belong to different languages and can be represented in three main modalities. The first is translation as a shared reference. So for example, we have two entries, triangle in English and triangolo in Italian. And these lexical entries are, of course, related to senses, and these senses point to the same concept. So we don't, yeah.
So in this case, sense and class is the same thing?
Sorry?
So in this case,
yeah.
Sense and class is the same thing? It's quite strange.
Two senses are
two senses are said to be equivalent as they denote the same class. I think that
the triangle, yeah.
And
the other two are the two senses.
Yes, but it's equivalent. When I say that senses are equivalent, but senses is not class.
Here is classes.
Here.
Yeah, yeah. Yeah, here are classes. Yeah. Yeah.
Yes.
Yeah.
Here is classes. Here.
Yeah. In the model, yes.
Yes.
We have seen. Okay. I can go to work. No, it's really interesting.
Left click. Again. You just put when you press something in the zoom, it goes to the zoom up, and then you have to go again back to the.
No, but we'll go back.
When you press the bar, it's when you move the app, it's like entering the app.
Okay.
So that's why you have to click again back in the Google. You understand? That's anyway,
No.
It's not important.
No, but I want to go back.
Yeah, now if you want to
with the backspace, when you are in your presentation focused, with the backspace from the
I can do anything.
left click, only left click, not right click, left click, press it again. Yeah.
Oh, sorry. Yeah, just to go back to the model. Yeah. This is a class. Lexical sense is a class, and senses are instances of this class. For example, if we have a lexical entry that is polysemous, is linked to the three different senses that are instances of the class lexical sense. That's why they are equivalent. I know it's really strange, yeah. And this sense are equivalent in the sense that, well, if we work in the same language, we would say that are synonyms because they denote the same concept.
It is quite strange from a pure linguistic point of view. It's not correct from a linguistic point of view. You can say that. Because in this case, it's a pure synonym. Perfect synonym. Yeah,
of course. Of course, you have also the relation near synonym if you want to use that. But we know perfect synonym doesn't exist. No.
Except, of course, if you focus on what it denotes.
Yeah, that's. Yeah. Yeah, of course.
Exist in different languages.
Okay, synonym is a relation in one system, one language. Okay, so for example, if you have two lexical entry, two terms, two words that denotes the same concept, they are synonyms. But you know, they are never perfect synonyms because they are different.
No, the actually
yeah.
But I wonder if synonym can be existed in two different languages.
No, they speak about equivalence.
This is equivalent.
Equivalence. Yeah.
Synonym is in the same language.
Yeah, and equivalence is between same languages, and this is a very strange concept. This of equivalence, because from a linguistic point of view, from a Saussurean point of view, we have a system of values. The language is a system of values, and there is no way of equivalence with another system because it's another system of values. The languages, each language is a specific system of values, so there is no equivalence. So that's the problem of translation. When we translate, we use another system and we cannot find exact corresponding values. Okay, because each system has, in each system, each word has some relationships with the other words, which are typical of this specific system, this specific language. Okay, so that's why synonym and equivalence in linguistics are very complicated concept.
In the logical representation, how we could capture these two words, triangle and triangle, as annotations?
No, we will see now. We will, we will have to create instances of these classes. So it's not with annotations, it's just from, yeah, ontological point of view. Yeah. And this is, I said, the first one. So you don't say anything from a linguistic point of view. You just say that senses are related to the same concept. So that's why they are equivalent, okay? They are considered equivalent. No, just
Great.
okay. And then translation as a relation between lexical senses. So this is another way to formalize translation. And this is this approach is based on the reification of the property translation. Maybe let's start by this. Okay, we have and this is the first the first way of formalizing translation, and then we go back to the second one. This is a very simple, it's a relation translatable as that links two senses. Okay, so for example, I have the sense triangle in English that is links by means of the relation translatable as to triangolo in Italian. Okay, it's very simple, it's a relation. The second way is a reification of this property. What is this technical term, reification? Reification is just transform a property, a relation, into a class. Okay, so that's why we have the other one way. We have the class translation, as you can see here. Then we have, for example, the instance.
It means that these two concepts of
Yeah.
classes can be different or not?
No.
Are the same?
Yeah, sorry, this is, this is a mistake, my mistake. They are, the same. No, the concept. Christoph is speaking about concept classes. No, it's the same, sorry. So yeah, they, by means of reference, is like we have seen here. Sorry. Yeah, sorry. That's my mistake. Yeah. Thanks, Christoph. And then we have the class translation, okay? And we have the sense triangle in English and the sense of triangolo in Italian that are source and target, respectively, of an instance of the class translation. And triangolo and triangle are linked to the same concept. Sorry, we have two concepts, but just one concept, okay?
I think why do you need this one? If a triangle are the same, following the famous Guillaume-Occam's principles.
No, it's a mistake. It's my mistake. No, just a mistake. My mistake.
Why do you need triangle? Why do you need this one? It's not necessary.
Yeah, it's okay. Yeah, you can use the relation that links, for example, triangle sense and triangle. If you want to use this reification, is just because, for example, you want to say something about this translation. For example, it's perfect, there is a degree of reliability, etc. Okay, so you want to attach more information, so you have to transform a relation, because you can not attach any information to an object property. So you have to translate, to transform this object property in a class. If you want to say, for example, that A is the translation of P, but this translation is not perfect, used by author X, etc. You want to add information about the translation process. Okay, so this is, thanks, Christophe. I missed to say this very important thing. Okay, so
just
yeah.
It could be tracing if you have two. It means that in this case, this term denotes, but if you are not perfect equivalent, how does it work? How can you find the newer translations? I mean, for example, I like the example of leader. Leader is a very good example. Since Chinese leader, how can I translate leader? Share, armchair? It depends on the context. So in this case, how can you represent here?
By using, okay, the concept could be the same, because we are on the conceptual dimension, so it's stable, but the differences from a linguistic point of view can be added to the class.
In this case, if that's not perfect, if that they don't denote, but I like the case of leader and share on an armchair, because share, for example, will denote a specific concept, even if you share the same ontology. When either does not mean the same. And if you want to find an equivalent, you are obliged to go for the conceptualization. In this case, it's not possible.
No. Okay. Unless you don't create two different concepts.
Well,
It is,
to share the same. Okay. Because sometimes when you are looking for the newer equivalent, you have to go to the ontology and to go for the conceptual relationships, no linguistic relationship. That's just it's very interesting.
Maybe you can add something to that class. Maybe we can think about adding some information about this translation, no? So it's not equivalent, the difference between
Since the main principle of OntoLex-Lemon is only to refer to ontology and teaching. And so
it's you're obliged to And this is the simple way I said to link two senses with the translatable as relation. Okay.
If I may change a comment also for myself. So the previous times is a means to attach some information about this relationship as you said it more perfect or more perfect and so on.
That's why I started with this, and then I go back, because this is the most simple, is the way we are used to think about translation as a relation between two senses in two different languages. However, if you want to say something about this translation, the author, the reliability, etc., you have to transform this relation to a class. And so you have to use this other kind of modelization. Okay, we will try both after, okay, just to have a little bit practice with this. I just show the model and then we will work with it, okay? And then we have the linguistic metadata line module that allows for describing metadata at the level of the lexicon ontology interface. And we will use in particular the class lexicon, because, for example, if we have a multilingual lexicon, we have one lexicon for each language. So for example, if we want to work with English and Greek, we have two lexicons, one for Greek and one for English. And the lexical entries are linked by means of the relation entry to a specific lexicon, okay? That's the formalization of that. So for example, we have a mathematical lexicon. You can specify the language in English, for example, and then, as I said, by means of the relation entry, we can link each our lexical entry to that specific lexicon. So let's start by working with Protégé and formalizing some linguistic aspects, okay? So I will give you, you can choose maybe one, we can choose one term. In English, maybe it's better for everyone. We can choose rectilinear figure, okay? And we will start by creating, first of all, a lexical entry. However, there is another step we have to do. Okay, please open your Protégé tool and where you have already built your ontology, okay? Please not change, because we have then to link the linguistic dimension to the conceptual dimension. Then you can go, if you don't have, I suppose you don't have the Lexinfo OWL, you don't have it, okay? So you can go online, just searching for Lexinfo OWL, and then you can just download it, okay? So just, sorry. Just go here, Lexinfo ontology. Did you find it? Okay, so maybe in the chat, is it possible to share a file? No.
Yes, it
Yes,
is.
is it possible?
Yeah,
I can also share for those who are.
yeah. Just give this one. Okay.
I will put also in the chat, okay? I put it in the chat, okay? So you can download, and then we will upload Lexinfo in Protégé. Please tell me when you are ready.
What is the key? Marina? Then I need to extra protection. Okay. Totally, also totally. Great.
Okay.
Yeah.
For everyone is okay? Okay, okay. So now you click on active ontology here, and you can see this panel, and we have direct imports, and we can import our ontology, okay, new ontology. Okay, here go, first of all, active ontology, then direct imports, and then let's
In the classes.
Yeah.
OntoLex, Lemon, elements, line, RDF, list, vocabulary. I have two classes.
Well, okay, let's see, huh? If maybe, yeah, I'm checking here and there is no all the, so please wait a moment. We will see. Maybe this.
Maybe non mi sono chiaro.
Just a moment, I check one thing. Does that work?
Yeah, this
Does it work?
If you downloaded the file of Silvia,
Yes.
maybe download the file that I sent, which is immediately from the web. The link that I sent you. Okay.
Just wait because the file is not. Yeah, we have also will be the module decomp. Just a moment, I will check why it doesn't work. For example, here we have, yeah, all the.
We also have a sound.
To κάτω δεξιά της Java αυτό το βγάζει πάλι.
Yeah, but it's not the correct file. Please wait one moment. I will check because there is another file.
Looking at the
This-
formalization of classes, very complicated.
Yeah, we have two class names errors.
Okay,
Noun, predicate, frame, for example. So it says no comment. Wow.
one moment because, okay, just to try to give you another file. Maybe you can download it better, but I will try to import another.
Works for me.
Voila.
Maybe
Does it work? Maybe I can send you another file. It's
send the one that download the one that you see as now.
yeah, I send you another file. Let's try with this. Okay, one moment. This. Let's see with this.
Yeah, to spend for.
The errors can be linked to the formalization in Lemon, can be, but if you can open, upload, and open is it there.
Just go back to active ontology and delete, and everything will be deleted.
Yeah,
Go
please
and-
delete. You
On the
will
right.
delete it, yeah,
Here,
yeah,
delete it,
anything
Yes,
you
great.
created, yeah.
and everything will be deleted.
Oh,
Okay,
Yes.
that's okay now.
Si tu veux chercher une classe sur un de ces lèvres, comment tu fais?
Je sais comment ça va.
Bien passer sur juste comme ça.
The last one.
And press here, and press reaction or picture.
Scene? Il cazzo mi sta
Yeah. And then the series of-
I've done it. I can do that's what the office.
Okay,
From the city.
but I can wait if you want to download.
I can.
Okay, then go slow. Yeah,
I will open it as a new folder.
yeah. For those online, is it all okay?
Yeah.
How do we know that we have imported the correct file?
And okay, you have to see imported ontologies, all these Lexinfo, then the module line, then OntoLex, then synsem. Can you see all these modules?
Yes, I can see
Okay,
OntoLex,
so that's
synsem,
the correct file. Yeah,
vartrans,
that's
yes,
why.
okay.
Yeah,
All right,
I sent. Sorry,
Thank
I
you.
sent the wrong file because I
problem.
wasn't able to see all the modules I shown you before. Okay, so
No
here
problem.
you have imported all the modules. Okay, so we have OntoLex here, that is the core. Then we have the synsem, so for synonyms and semantics aspects, vartrans for variation and translation, and decomp for the decomposition, and line for metadata. Okay, so we have imported, uploaded all these files. Okay, so now let's go back and let's try to find, okay, lexical, a lot of classes, some lexical entry, okay? It's in alphabetical order. So you can find lexical entry, you can find lexical sense is a subclass of meaning. Okay, so after we have to look for lexical senses, we have to open meaning, and then we find lexical sense. Okay, so first of all, let's create our first lexical entry. Now we are populating, okay, the ontology. This is the hierarchy or the object properties. We imported all the data properties or the axioms. And now we are populating with our lexical data, with our terms, with our terminologies, okay? So let's start. We have to create an instance of the class lexical entry. So go to individual by class. Please, before click on lexical entry and then go to individual by class. And then we can add by clicking here on this button, our first instance. That is, for example, we said the trilateral figure. I suggest that you use it's impossible in Protégé to use the same label for different entities, classes, object properties. So you have to differentiate it. So you can use, for example, trilateral figure underscore lexical entry, for example, okay? So then we have to create trilateral figure sense, etc. Okay.
But a question could be, why do I create this population in English and not in Italian?
Yeah, because it's international, more international.
Great. So that everyone can get that.
Yeah. Yeah. Why not in Greek?
Why not? Exactly. Why not in ancient Greek? Protégé doesn't happen.
to just remark, it's
Yeah.
possible to create an instance of lexical entry when lexical entry can be specialized in different classes. So it's A2 from a conceptual point of view, it looks quite strange when a concept of a class has several subclasses.
Yeah.
If we create an instance,
Yeah,
it's much
in this
under
under,
subclasses,
yeah.
not directly. to the
Yeah,
class.
we can also create, for example, trilateral figure under the specific subclass that is multi-word expression.
Because in this case,
Yeah.
what you have created, is it a part, a phrase, a word?
Yeah.
What is it exactly?
Yeah. We can specify better this. Yeah. We can, for example, create this entry as a kind of, oh, sorry, as an instance of multi-word expression. Yeah.
And in
Is
this
this-
case, you have created an essence of a lexical entry, but what is it? Is it
Yeah.
so-
You,
Make
yeah.
sure-
okay, you can use a lexical entry if you don't want to specify what kind of lexical entry is it. You are not interested in specifying that is a multi-word, that is a affix. I know that it's an ontological point of view, yeah. Well, let's do that because it's necessary, because we will see that after, by using the module decomposition, the decomposition is the decomposition of a multi-word. So if we go back to this, we can change here and then put, for example, as a subclass, sorry, as an instance of multi-word expression. I wouldn't specify which kind of multi-word expression, that's enough. Yeah, that's it. Okay.
Sorry, how did you change it?
Sorry, Fotini. Well, you click on the instance you created, for example, a trilateral figure, and then you can change here in description. You can click here on this button, edit, and then you can choose by clicking on class hierarchy, the correct class. In this case, multi-word expression. Is it fine now?
Yeah, fine.
Okay, perfect. Okay, and then as we have seen, just to recall the model, we have created a lexical entry, or as Christophe said, more specifically, a multi-word expression, okay? And then we create some forms. Well, English is a very basic language, so we have just plural. We can create just this form, okay? We have no inflection on for cases, or number is just singular or plural, so it's we have just another form. So we go to the class form. Yeah. And just create another instance that is, for example, trilateral figures. Sorry, trilateral figure form, and then we will see. Yeah. Just create this, and then we will specify the form, the written representation of the form.
For that, you use the data property, right?
Yeah, now, yes. No data, object properties to link the multi-word expression to this its specific form.
Yes. So we can agree to.
Yeah. I will do. Is it okay for all one? Okay, so now let's go back to our entry, lexical entry, multi-word expression is very complicated. We have to, connect all these things, and it's not so easy. So we can connect by the object properties. Let me remind, it's a canonical form.
The name of the relationship,
Yeah,
and also the name of the individual.
I don't know if it's,
I mean,
Yeah.
that's in Mac it doesn't work. The control space
yeah,
that
Yeah,
doesn't
it's-
work
yeah.
It
I will try,
works.
yeah,
because in Mac it doesn't
Yeah.
work.
yeah.
Yeah, it doesn't work.
It's really complicated, but in other, because you have to have it
Remember,
here. Remember,
it's
it's
not
impossible. Yeah, there are a lot of relation object properties, a lot of classes, but in this case, we have the canonical form that is the singular, okay? And then we enter the individual that is trilateral figure. I don't remember, maybe with this, with the,
F small.
Lexical.
The F-
no, with form. Yeah, no,
No, you just put an underscore there, and the F is not capital.
wow.
Ah, yes, I'm trained. The training with Christoph.
This means that this lexical entry, this multi-word expression, has a canonical form that is trilateral figure form.
But if we want to see the
The TCC
inverse, we have to go to the, again, it's not automatically
No.
done, right?
No, and I don't know if there is an inverse property of canonical form. I don't think so. I think that is a property that has as a range lexical entry, and as a domain lexical entry as a range the different forms, but there is no inverse relation. And then we have to specify that canonical form is a singular, okay? So we go back to our, why this,
Also the representation form.
yeah, to our form,
So
and then we add, no, it's no data property, sorry. It's an object property, I don't remember well. Singular. Let's check, because there are a lot of singular number form, okay? Let's see this singular number form, yeah. And then with singular number, this form that is, let's see, trilateral figure form, and by means of the object properties that is called singular number form, we link to the individual singular.
and now what about its representation in English, for example?
It's just, this is in English.
Yes, but oh.
Yeah,
what
this
is
we
the
are working.
representation form? Where is the representation form of lips?
This is the form.
Yes, but it's not the representation form in the text, this one, the name of.
Yeah, the written representation. Yeah,
So you have
yeah,
now-
yeah.
So you have not finished.
Yeah. No,
Not yet.
not yet. Are okay with us with this? Okay, now we have to add, no, I think is, let's check the written representation. Where is written rep? Okay, written rep. So it's a data property. It's a written rep under representation. No,
The last one, yeah.
yeah.
Mhm.
And then we write the form in English. So trilateral figure.
And you can also specify the language here, right?
On the lexicon, we
On
will
the
see now.
Okay.
Yeah. because you have to say that this lexical entry, trilateral figure lexical entry, belongs to a lexicon, and you can a specific lexicon that is an instance. It's related to an instance of the class lexicon, and this instance is you can specify that with a data property that is in English. We will do that. We link this lexical entry to a sense. Okay? So let's create a sense. Let's go under meaning. Let's create under the class lexical sense a sense. Okay. So for example, trilateral figure sense. Remember.
Yeah.
Raffaele is
So
the
complex.
best assistant. Okay. Did you create? Potini, I waiting. Yeah. Also. Okay. Then we have to go back to our multi-word expression and connect the sense, okay, by means of the relation sense. So, because the first entity is lexical entry. So sense, forms, everything needs to be linked to a lexical entry. Okay, so this is the core. So let's go to our multi-word expression and then link our instance by trilateral figure sense.
This is the property.
Oh, sorry. Yeah, sorry. The property is a sense, of course. Sorry.
I sent.
And then, yeah. And then the range of the property, trilateral figure sense. Yeah. Okay.
And can you now define the sense?
Yes.
Data property?
Well, you can, for example, add by annotation properties, definition natural language. Otherwise, you can define but in a more formal way, obviously. But for example, you can define by using synonym relations. That's the only way to define. So let's see. Well, together, lexical entry, a new lexical entry, okay? That is figure, okay? Figure entry, for example. Then, so let's help him. What next? So let's go back to multi-word expression. No, sorry, not multi-word expression, sorry, a lexical entry. We can define that figure is not only a lexical entry, but more precisely is the lexical entry is a superclass and has 3 subclasses: word, multi-word expression, and affix. What figure entry is? A multi-word figure, a word. Yeah, so let's change this and maybe we can, no, not here. Yeah, figure entry, we can just change and put this like a word, okay? Just to be more precise.
Which other words?
There are other,
Specialized.
yeah, no, it's okay. Because, for example, you can say that is a noun, okay? But you can also say that with the object properties. So it's
Yes,
enough, I think.
all these subclasses are special.
Ah,
All
Yeah.
of them are special.
Yeah.
So it means by.
yeah, it's because a word, if a figure can be an adjective,
Yes.
and a position, an adverb.
Sorry, I
yeah.
didn't hear all of them are. I didn't hear what.
Disjoint.
Disjoint. Ah,
Disjoint.
okay.
Disjoint, yes.
Okay.
Yeah. Figure, yeah, is a word. Word is under lexical entry. I have.
I press the command S and
Is it okay? If you put under lexical entries, okay, it's not a problem, just to,
I press command Z and then
no, go to lexical entry. Instances. No instances, one.
and I press undo.
Okay, so we
Yes,
can
because I
do-
wasn't sure.
No, no, okay. So go to Word
Okay.
and then create. Oh, okay, you already created it. Yeah. Okay, now we have to link this word by means of the property sense to the figure sense, but before all, we have to create figure sense, okay? So let's go to the class lexical sense. You can see how is it complicated to build a lexicon by using this model. Okay, so let's go to lexical sense. That is under meaning. Lexical sense. I create a new instance that is figure sense. And now I can relate our word figure to this lexical sense. So let's go back to our word figure. Now let's choose the object property sense. And the range is figure sense. Lot of steps.
Yeah.
Yeah.
it's very complex.
Yeah. Now we have two senses, figure, 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 and trilateral figure. And we can say that figure is a hypernym of trilateral figure. So we can link these two senses by means of this semantic relation that is hypernym. Let's just see how is hypernym or hypernym. Yeah. Hypernym. So let's go to the class lexical sense. Let's choose figure sense. Let's open the object property accession. Let's write hypernym and then trilateral figure sense, that is the range of this relation.
Okay, so you define the hypernym and the hypernyms through the senses.
Yeah,
Okay, even if you haven't defined the senses.
Yeah,
in a more
because-
formal way.
no, because the formal way to define senses is this. It's just
I got it. From the
relationships between the entries of a lexicon. I said that is really Saussurean thing because you cannot define an entity unless you don't define the relationships that the entry has with the other entries.
yeah.
Okay,
Yeah,
it's a relational perspective.
Yeah.
Okay, so now there is a problem with Protégé. You may another problem. According to the OntoLex-Lemon, you can connect, link a lexical entry to a property, to a class, to what you want, okay? But in Protégé, you have to create instances and then link instances by means of object properties. So in our conceptual dimension,
Yes.
yeah.
It's me.
Okay, stop. He's ready. Yeah.
How are
That's-
we going to do that?
Yeah, just a workaround. I create an instance in the class, under the
Okay,
class.
So there is a
You have
class
another-
triangle.
For example, the class triangle.
How are you going to link your individual to your class triangle?
I cannot do this in Protégé.
Except if you say that the class can be an instance of itself,
Yeah,
which is all
yeah,
cool.
yes, yeah. With panning.
Happening.
It is part
But-
of the handbook on ontologies and it's
Yeah.
déconseillé. It is considered not one of the best
Yeah,
practices.
yeah, but it's the only practice you can, if you want to link by using the Protégé,
Except
it's,
if you create a concept, a class, let's just say concept, and to say that your class is an instance of the class concept. Perhaps is
yeah, that's the way we would do.
Okay.
Yeah, that's the way we will do. Yeah. But yeah, it's strange. It's just like a walk around, no, just to make it possible. Because from a theoretical point of view, you can link a lexical entry to anything, to an object property. Of course, for example, some predicates, some verbs are effectively connected to object properties.
It's mainly due
It's
to the fact that everything it meets in the same environment, a logical environment, but everything is represented using the same system.
Yeah.
Yeah.
But they are two different
Yeah.
dimensions.
So,
With the same problem.
yeah. So now we have to do that. So we created a triangle today, this morning. I cannot find why. Yeah, figure, rectilinear. Okay, rectilinear figure, it's okay. I have just this. We create an individual rectilinear figure. Yeah,
Of
the
this
class.
is-
Yeah.
Wow, very difficult to manage.
yeah.
Yes.
Otherwise,
Otherwise, you can copy the URI, you copy the URI, and you use a type. When you create an instance of, create an instance and put the URI on your class. You can do
okay.
plugin.
Yeah. Yeah.
But do-
Yeah. But maybe today we can do
Through
that.
there,
Yeah.
through the
It's
options,
yeah. But it's
No.
yeah.
No,
Yeah.
This way is better. No, your way is better.
It's a walk around. It's
Nevertheless, from a logical point of view.
No, it's-
better. It's very better. Too much thing to
I do that.
duplicate.
Typically I do that when I do to connect these two dimensions. Yeah. So now we have an instance of the class rectilinear figure, that is rectilinear figure. And now we can link the sense rectilinear figure to this concept that is an instance of the concept rectilinear figure by means of the property denotes. So let's go back to our sense.
And okay, this is good. I will ask you another question.
Okay.
just after.
Let's go to our lexical sense. What figure? No, trilateral figure. Yeah. Okay, let's go to our trilateral figure sense. And then by means of the object properties denotes, we link this sense to our concept, that is trilateral figure. now we have these two dimensions linked to each other.
I'm wondering,
Yeah.
Concerning how you do the modeling and then the population. Let's say we have a trilateral figure that it is a specific figure, like a trilateral figure of Raphael. When you
that-
do this thing,
That if you work
if you
with,
want to create a new one, you will create a subclass of, and then you will create also.
this seems to be an instance, a
Yeah.
trilateral figure of Raphael,
Yeah,
drawn by
but-
Raphael,
Yeah,
for
exactly.
example.
It will be an instance of the trilateral figure.
Yeah,
And
Yeah.
then if I want
the
to
real
create-
instance of, it makes
and
sense.
when I want to create a term of my trilateral figure,
Yeah, you can name it, yeah,
how?
in this way. So for example, you have the class trilateral, from the conceptual point of view. You have the class trilateral figure, and then you have as an instance your trilateral figure. This is an instance, okay? Because, for example, you drawn a triangle, okay? Then this instance is connected to a sense or directly to a lexical entry in the lexical dimension. And the lexical entry is the name
Yeah,
used
okay.
to denote this instance.
Okay, but when you define here,
Yeah.
when you did the figure here, the trilateral figure. So if I had a trilateral figure, I would create here a different instance,
Yeah.
trilateral figure.
Yeah,
of I.
another instance, yeah.
But in this way, this thing,
Yeah,
and my,
yeah.
my,
There are-
they're the same.
No, it's like
They're the same,
no.
instance of the same thing.
Yeah,
And
there are the
therefore-
instances of the same things, but as you and me are the instances of the same class humans, for example, okay? We have two distinct instances of the same class. The problem is that it doesn't make sense, because it is not an instance, it's just a walk around. Yeah.
and this is what I mean, my
Yeah.
instance and this instance will be
The same name, yeah,
Same.
it is, yeah.
and they are not the same, because this is the conceptual, it's not the.
Yeah, they are not the same, but they can be named in the same way, but they are not the same. They are two instances,
Yeah,
two different instances. The problem is that it's not an instance.
this is not.
It's just
Yeah.
But if you want to use Protégé or panning or this, you have to do
Yeah.
something, because
Yeah,
you have
sure.
to link individuals. Okay,
Yeah.
object properties link individuals, so you have no other way.
Yeah.
It's just if you want to use, from a theoretical point of view, remember our competency questions. For example, the first one, just to conclude, okay? The first one, what are the hyponyms of the English term triangle? We can now say that, for example, is obtuse angle triangle, okay? So we can, because we formalized the relation of hyponymy, for example, in this case, between triangle and the other terms that are hyponym of triangle.
So just
Yeah.
say in very few words, what is this? What is this?
Sorry, this is a query in SparkQL, okay? So we can also next time maybe try to make some queries by using the plugin in Protégé. Could be useful, because Protégé has plugins to
Which does not work.
really.
Yeah. In Mac, it's
Yes.
never working.
And
I always have
even
to
my
upload.
computer, sometimes it works. And
Yeah.
doesn't
Yeah,
work.
I don't know.
So
But it
just-
depends also from the dimension of the ontology, I think.
No,
No,
for me, it does not work.
Is it?
No.
Okay.
I always have to upload.
I have
to
all
separate
these, it
file.
doesn't work in my
All
computer.
these too,
Yeah.
doesn't work.
Yeah.
Yeah.
That's a problem. We can write to
Yeah.
those
But
that,
it is no longer mentioned.
okay.
It is no longer mentioned.
Yeah.
It's really important.
So we have another query. Sorry. what are the French, Italian, Greek translation of the term obtuse angle triangle? Let's suppose, for example, that we have created three lexicons. We have created the entry in Italian, in French, and in Greek, and we have related these lexicon entries, for example, by means of, as you can see here, the relation, the object property translatable as, we can retrieve some results, such as triangle obtuse, triangle obtusangolo, amblyogonion, trigonon. And then, yeah, I have to click there.
Okay, double click in the grouping, great.
Okay. And then the last query, for example, we have formulated today what terms are used in French, English, Greek, and Italian to designate the concept of obtuse angled triangle. So this query linked the two dimensions. We have the conceptual dimension, the concept of obtuse angled triangle, that we have defined in the ontology, and then we have all the lexical senses that are connected by means of the property sense to this concept. And you can have these results. So you can query both the dimensions, just the linguistic dimensions. If you are interested in, for example, the translation relation, hypernym, all the kind of relations between senses, you can, of course, make queries about the conceptual dimension, but you can also combine the two dimensions. And for example, let's see what are the terms that are used in Greek, in ancient Greek, to denote a specific concept, etc. Okay. So let's conclude with the Christoph question. Well,
if I want to phrase my
yeah.
questions, so it's very interesting. If I am interested in terminology,
Yeah.
in the ISO sense, how can I do? Because it remains an extensional approach. Since the base and individuals, and when you define a class of concept,
yeah.
and class is defined as a set of properties, which is the set of individuals such as they define these properties. When you are interested in defining concept by comprehensions,
yeah.
it's about properties.
Yeah.
It means a second order.
Yeah. Is it not possible? Well, of course, it's not possible in Protégé. The only thing you can do is just to query and retrieve the formal description of a concept and another concept, and then try to compare this according to, for example, today we are working with, we were working with the restriction properties. So just compare, yeah, the intentional description by means of restriction properties.
Can simulate the second order in first.
We can.
So we can.
Yeah.
It was the last.
Yeah.
But in this case, it's very complicated to manage the essential characteristics, especially if you say that the essential characteristic of a subdivision criterion are exclusive to each other. So it's in this case it's awful.
Yeah.
But it's possible.
Yeah.
And so, for example, Teddy with very simple ontology, from crater ontology, very simple in log, written in the language. When you generate the RDF, it's a
lot of cycles, triples,
But you need to do that in order to query, also to upload in Protégé in order to verify the consistency.
Yeah.
But it's, I really love Protégé from a logical point of view. I like this idea to define not concepts but classes based on the fact on what an object is, but according to the relationships between objects. It's a very different way of thinking, but I think we need to involve.
Yeah.
But I mean, if the most important thing I believe concerning Teddy and Protégé and the export in RDF is to understand the logic behind it. When okay, it's a massive file, when you open it, it becomes very surprising what it is created through the system and through the application. But if you understand the background of it, and when you try to understand the logic behind Teddy, then everything is easier, and you can query. It's not that complex to query Teddy if you understand what it is in the backend.
Yes, you are
Let's
right.
say.
We need to, it's the reason that why Maria will propose a training on Teddy.
Yeah.
Unfortunately, I didn't do it so far, mainly because lack of time. But it's also it could be interesting if you can do it when you are here, because Silvia has a different view, and I like when we are not agree. It's because of course they are.
The thing is that when we don't put things on our calendar.
Yes, I know that. Yes, she.
Yeah. Okay. Okay.
Sorry, I
Now
opened
I'm
another
student.
ontology. I don't know what I'm doing. Okay, let me just check if this is our ontology. Maybe yes. Yeah. Okay, we can of course save our ontology. Okay, save as RDF. Let's call it Euclid ontology. TALOS.
TALOS.
Oh, sorry. Also. Okay. Then we go. what's this? Just to remember what. Okay. Okay, and now we will open. Okay. In this way, you have an RDF OWL file. Okay, you can, for example, put it on GitHub. If you have your ontology with the conceptual linguistic dimension, you can put it in Clarin, on Daria, or on the platform to share. Okay, your ontology. Let's see how is it the output. No,
It's the same.
no,
You want to open
yeah, in
using
notebooks, yeah, yeah, yeah. Notebooks.
Don't use the text. So the text is quite good.
Okay,
With color and
yeah,
yes. So yes, I like much carefully.
and this is our file, for example, okay, all the classes and all the relationships we created, okay. So this is the output of our ontology. This is the ontology I've created before, because I see that there is Greek definition, other definition, okay. So that's the output.
So we can store data inside.
Next Monday. Bye, and thanks to all. Close recording, please.